gonna get started. So if everyone who wants to take a seat takes a seat, we'll...
Cool. Okay, hello everybody. First of all, thank you for having me here today. Thank you guys for organizing this. Today I will talk about FerretDB, which is open source alternative for MongoDB, and disaster recovery plan. This talk should be covered by two people, to be honest, because disaster recovery part is talked by Elotl team, but yeah, we have a recording of this part, so yeah, let's do that. If you have any questions during the presentation, cool. Just feel free to interrupt. There is not a lot of us. I will be happy to just provide you answers as quick as possible. For the beginning, I will tell you why we decided to create FerretDB and what is it. Then we'll slowly move to disaster recovery part. And as a cherry on top, I put the I just want to give you information about other Meetup group that we are spinning up, so document database community. About me, I used to work for Percona. I used to work for Exclusive Network. It was the biggest Valga distribution for Central Eastern Europe. Feel free to ask me any kind of technical question. This is my LinkedIn account, so if any of you have something to, want to go deeper or whatever, just please let me know. Personally, what is the most important part from myself, I'm the open source enthusiast, so yeah, this is the technology I love. I want to start with a statement that working with databases should be as easy as possible. And what does it mean for me? I just want to be sure that everything works correctly. There is no vendor lock-in, there is no legal constraints. If I'm coding, if I'm focusing on my application, I don't want to be really focused on the database part, to be honest. So we took the developer exchange survey. We checked what is the kind of what kind of databases developers like to use, and as you can see, the first NoSQL database here, which is on the screen, is a MongoDB. Why? MongoDB is a cool technology. You don't have to think about schemas when you're talking about NoSQL. You're just coding, it's working. But there is only one big constraint connected with this technology today: the license. I'm not a lawyer. I don't want to give you any legal advices here, but we asked our friends, our customers, our users, what is the biggest constraint with SSPL? The biggest constraint is that it's no longer open source and it's a vendor locked-in technology. So as you can see, no open source, MongoDB, Atlas is something what is that people are MongoDB sales team is pushing to the customers. There is a lot of legal risk because there is no clear license text. And that's why we decided to create a kind of alternative, just to provide something for people who like to use the technology, just alternative open source solutions. So what we decided to do, we create a compatibility layer. It's written in Go, and basically it's fully open source. You can go to our GitHub, you can check it, you can comment, you can vote. Everything is just for you to be sure that we are going the right track. And we are translating NoSQL to SQL and using PostgreSQL for the beginning as a layer. Here is the explanation about what we took. So MongoDB drivers. This is still Apache 2.0. This is something that we can take and we can use because MongoDB don't want to change this kind of licensing here, just to provide tools for MongoDB compatible GUIs, whatever. And we don't touch anything what is connected to SSPL. We totally, from scratch, write FerretDB as a transition layer, and then we can use Postgres as a backend. What does it mean? You have a fully open source stack, so it's no constraints for you to go. For us, MongoDB compatibility means that from the application perspective, from the developer perspective, everything should work exactly the same. So the query language, everything, the behavior should be as possible close to MongoDB as it's possible. Here you have some screens from my environment. There is a Mongo, so yeah, you can see that I'm connecting to FerretDB, and it's a quite old one, so 0.9, but it's just behaving like a MongoDB. There is on my Docker desktop there is on 2717 port FerretDB running, and MongoDB Compass, when I connect it to FerretDB, it's logging just like next another MongoDB 6 community instance. So from the different frameworks, from the application point of view, we are just using and behaving like MongoDB, but in the end, you can create a fully open source stack. There's some examples of the different languages, different frameworks that are already working with FerretDB. Backend. So why we decided to start with Postgres? First of all, big community, huge supportive community, open source, and existing JSON compatibility. What FerretDB is doing, it's translating binary JSON code by MongoDB to JSON-B in the end. Also, different flavors of Postgres. For us, it's important to be as flexible for developers as possible, so whatever you want to use, FerretDB is transparent, so you can take different kind of your favorite flavor of Postgres to be sure that it's working with FerretDB. Today, Elotl team took a Percona operator for Postgres, and based on that, created the disaster recovery scenario. The idea of FerretDB, I'm talking a lot about flexibility, it's that we also want to provide other different backends in the future. SQLite is already existing because our customers ask for something extremely lightweight with small footprint for mobile devices, for Raspberry Pis, network devices, things like this. Our friends from SAP HANA are working for Handler for HANA. So yeah, this probably will be extremely performant alternative for MongoDB. And for us, the next obvious step is MySQL. It's also happening. You can check our GitHub. There is an open issue regarding that. And it's almost done to also handling the MySQL. So to sum up about FerretDB, we are currently in 1.20 production-ready version. It's more than 8,300 stars on GitHub, more than 370 forks, around 100 contributors who are already working with code. So yeah, a lot of people are just giving us feedback, and this is the whole community-driven project. So the feedback is the most important for us. It's still a young company, less than 2 years old. How to start, and the easiest way to check what is the capabilities of FerretDB? You can go to LiftCloud page. There is a full documentation done by team, mostly, about how to set up the Postgres instance with FerretDB on top. Regarding Elotl, I don't want it to be really deep here. Basically, what we are trying to do together is to create a scenario that provides full disaster recovery, and we choose Elotl Nova to do that. It's a policy-driven multi-cloud, multi-cluster orchestrator. If you want to do it more, let's say, by your own, let's go to our blog post. There is a full guide how to set up Elotl Nova with FerretDB, and it's done by Marcin Gwóźdź. Regarding the hands-on, it will be, as nobody from Elotl is here, on 14 March there will be a meetup in document database community. I will tell you a little bit more later. But they will be doing the full hands-on. It took around 1 hour to see how everything is working. And now let's go to the Elotl part. As nobody can be here, they just create the recording. So let's listen.
FerretDB using Nova. The work presented here was led by Marcin Gwóźdź of Elotl. Let's begin with an introduction to what Nova is. Nova is a multi-cluster orchestrator that helps manage a fleet of Kubernetes clusters, irrespective of whether these clusters are kind clusters on your laptop or cloud provider managed clusters, or a combination of the two. Nova's capabilities for fleet management can be categorized into day 0 ops and day 2 ops. Let's look into details for each of these categories. For day 0, Nova primarily maps your workloads to specific clusters in your fleet. This mapping is captured by what we term as a schedule policy, which is a Kubernetes custom resource that the user defines. These schedule policies can be static or dynamic. In a static policy, the user clearly specifies which target clusters their workload needs to run on. So for example, I could request Nova to run my application A on clusters 2 and 3. In a dynamic policy, such as capacity-based scheduling policy, the runtime conditions on your fleets as well as the resource needs of your workloads will determine at runtime where your workloads will run. For example, you could request Nova to run your machine learning training workload on any one of your team's dev clusters that has sufficient capacity. So now, with the help of Nova scheduling policies, your workload is running on the clusters you need them to run on. Now let's look at what Nova can provide as Day 2 fleet management support. For Day 2 operations, Nova helps with 3 different aspects. The first one is workload migration. This allows the user to move their workloads from one cluster to another. These migrations are triggered either by a change to the scheduled policy or, more interestingly, triggered by changes in the resource needs of your application. For example, for your training machine learning workloads, if you needed to change a deployment's replicas from 10 to 20 and its current target cluster does not have sufficient capacity, Nova can intelligently determine this and migrate your workload to another cluster with sufficient capacity. Let's move to just-in-time cluster capability in Nova. This allows Nova to create new clusters from existing cluster templates triggered by incoming workloads. This means that you don't have to be paying for your cloud clusters when you don't need them. The JIT feature also helps with cost optimization in another way. It allows a cluster without workloads to be brought into standby mode. That means 0 worker nodes, or even deleted completely. That is, both worker nodes and the control plane can be brought down. Now that we have a sufficient background on what Nova is and its role in fleet management, let's move to the focus of this talk: automation of disaster recovery. Disaster recovery refers to the process of executing a predetermined DR plan that is needed to bring back your application, in this case your database, back to its fully operational state. The failures of interest here are cluster level failures, zone level failures, or even region level failures. So first let's look at why do we need to automate in the first place. Automation significantly reduces your recovery time objective. This is the time from which your failure occurs to the time when your application is back into its fully operational state. Every bit of outage time that is reduced helps reduce loss in terms of revenue and reputation for your business. Secondly, it reduces potential user errors in handcrafted automation scripts that need to be carefully run during an already stressful situation. And most importantly, it allows for fire drills. A DR plan that is not well tested can easily go stale. One that is automated will encourage your teams to tolerate these fire drill interruptions frequently. Next, we'll talk about why do we need to use an orchestrator like Nova for automating DR. Nova is uniquely positioned to both have visibility into your cluster fleet as well as control of the workloads running on your fleet. This makes the automation possible. So, as shown in the diagram, if your primary database is running on workload cluster 1 and your standby is on a second cluster, Nova can make modifications to these workload manifests on the fly. For example, for invoking standby promotion, which is an essential step in the DR plan. Another example is end-user traffic redirection, which will require a change to your load balancer configuration. Finally, we look at the benefit of how Nova implements this automation. Nova as a management tool presents a Kubernetes API to the user. This allows for the entire DR workflow to be captured in a Kubernetes native way through a custom resource called the Nova Recovery Plan. Let's dive into this recovery plan in the next slide. The Nova Recovery Plan captures a sequence of steps that needs to be enacted as soon as a failure is detected by Nova. Each recovery plan is associated with a unique label called the alert label that you can see here in the code snippet in the slide. Such an alert is pushed from your management setup to Nova. After the alert label in the recovery plan is a list of steps that will be invoked in the provided order. There are 2 types of steps. A path step is one in which we specify how the manifest of a running workload needs to be modified. In a read step is one in which a runtime value is read in by Nova and will be used in a subsequent recovery step. In the example, the path step modifies a field identified by the path spec.standby.enabled and sets its value to true. This would be one part of standby promotion. In the following read step, we read in a field path, load balancer.ingress.hostname, and this IP or hostname will then be used to reconfigure your load balancer for end user traffic redirection. This is only a simplified sample of a recovery plan. Next, let's look at how we would capture DR for FerretDB setup. This diagram shows one possible setup for DR for FerretDB using Percona operator for Postgres. On workload cluster 1, we see the Nova agent, Percona Postgres cluster, and FerretDB. Percona is set in the primary mode here. On the second workload cluster, we see the same workloads, with one difference being Postgres operating in standby mode. Both the Postgres clusters use an S3 bucket as their data store. In the third workload cluster, HA proxy is deployed and is used as a load balancer between the primary and the standby. The recovery plan for FerretDB has 4 phases or steps. The first is a patch, which transforms the primary to a standby. The second is also a patch that transforms the standby to primary. The third step is a read, where the host name of the standby is read in. And the final step is a patch to the HA proxy configuration so that new Mongo client requests will be forwarded to the new primary. Let's now look at what happens when the primary cluster experiences an outage. At the time of an outage in the primary DB, a predefined alert is generated by the monitoring stack and sent to Nova. The corresponding recovery plan is selected by Nova and converted into an internal structure called the recovery run. This can be queried if necessary to determine the status of where we're at in the process. At the successful completion of the recovery run, Mongo client requests are redirected to the standby cluster. And voila, all of this was possible without any user intervention. We'd love for you to try out Nova. The key takeaway from our session is that Nova is a fleet management tool that can enable easy automation of your DR workflows for powerful databases like FerretDB, Postgres on Kubernetes. The easiest way to try Nova is through the GitHub link on this slide. We'd love to hear from you. If you have feedback, complaints, or other requests for Nova Day 0, Day 2 ops, please write to us and join our Slack channel. Thank you.
Okay. Okay. So as I said, 14th of March there will be a full hands-on in the document database community meetup. So feel free to join and learn a little bit more from Slack and Maciek. And to sum up, why to choose FerretDB? If you are looking for just a flexibility and full experience of NoSQL databases, but on SQL not to provide additional environments, fully open source, this could be a right choice for you. Just feel free to test, feel free to give us our feedback. We are community-driven project, so anything what is important for you is also important for us. Our roadmap is fully available. Currently, we are strongly working on performance, just to be sure that we will be at least as good as MongoDB. To disaster recovery, feel free to contact me or Elotl team. We'll be happy to discuss this more. Last but not least, document database community is a bi-weekly meetup, so feel free to join. It's just always online. Yesterday there was a meeting about the administration. The next one is probably about the Elotl team. That's all from my side. If you have any questions, I'm here all night, so yeah, we'll be happy to discuss tomorrow. Perfect. Yeah, thank you.